A few years ago, I was the first person to kind of present it to the world, and it's grown a lot since then, and I've managed to build a lot around it, so I have lots of applications to show you guys today. I'm super excited to share. So how many people are, real quickly, how many people are already experimenting here with Atlas Search, have tried it? Okay, well, okay, good. So how many people are, well, anyway, this game plan, we're sort of abbreviated in time because we're starting late, so I'm going to try and get through this first part quickly. But I'm going to talk very briefly about why we built Atlas Search and the problems that it solves. Then we're going to start building out queries right away. I'm going to talk about indexes, analyzers, what they are, why they matter, how they work together. And then I'm going to talk about the architecture. It's important to understand how Atlas Search works with MongoDB, what goes on underneath the hood, so you can make really good decisions about your performance. And Paul from Trimble here is going to talk about some of those things in a later session today as well. And then we'll wrap up with some questions at the end if you have it. But I will be here all day. If you have questions that we don't get to during the Q&A session, I'm happy to take those as well. So, and all of this, if you've noticed, we're doing with a soccer theme. And you might think, I must be really into soccer. And I am not actually really into soccer. So I have my best friend here from high school for the last 30 years, and she will tell you that the only thing I know about soccer before was I used to drive her little brother to soccer practice, and then my kids started playing soccer. I have a German son. She's known me 3 last names ago. I have a German son and a French daughter, but I'm just from Rockwell, Texas. So they all play soccer, and I actually don't know anything about it. So who here doesn't know anything about soccer at all? Okay, good. I'm going to be calling you later. I'm going to need somebody to come up and practice. So I built this app to sort of help me when my family starts talking about soccer and all these players whose names I don't understand. Actually, let me go back. Oh, I'm missing a slide. But one thing that I do know how to say in French is allez les bleus. That's like the only part of soccer that I actually know how to say. So Bear's pretty happy with it. But I have names here that I have, when they say people like this, I think the first one is Mkhitaryan, and there's a Szczęsny, and that's about as far as I go. So when my family, they start talking about these players, I can't even Google them. So in this application, we will be able to, oops, these slides are a little out of order, but in this application that I built, you will be able to come up and somebody's going to say a really complicated name, and we'll be able to find that player even if you don't know how to spell it. So, with that, why we built Atlas Search. So, if you've been using MongoDB a long time, you may have used search in different ways. You might have done the $text operator, which it was functional, but it was a little cumbersome. Hi, if you're, oh great, thank you. But it was a little cumbersome. Or you might have had maybe third-party systems and servers that you would use and sort of connect your MongoDB data to those systems. But that came up with its own set of problems because you'd have to obviously pay for those systems, but you'd have to secure them, scale them, and then find some way to keep your data in sync from MongoDB. So what we saw is what some of these companies were doing is these systems, what they do is they actually call Lucene, this very popular battle test that's been around for over 30 years, open source library. So what we did is we just brought Lucene directly into Atlas, and that is how we built Atlas Search. So with that, we're going to start building out our basic search query to understand how we made search available in MongoDB. I'm going to talk a little bit about the aggregation pipeline. Mike talked about aggregations earlier. If you're using MongoDB, you're probably already, hopefully, you're familiar with the aggregation framework. It's a really powerful tool that you can take data in, do certain stages, apply certain stages, transform that data into other stages, and then get your results. It's great for getting analytical insights into your data. It's great for, I actually use it to clean data. $out is my favorite operator. I always make backup copies of my data that way. But the nice thing is that if you're already doing this and you start working with search, then you already know everything you need to do to implement search, because search is actually simple aggregation where $search is the first stage in that. So with that, let's build an aggregation real quickly. Let me see if I'm going the right way. So here in Atlas is our data set. So I found this data set online of soccer players. It's got about 20,000 players in it. All sorts of fields. I have strings, I have numbers. I don't know if you guys can see this, but it's about 100 different fields in it. Their dates, etc. So the first thing to create an Atlas search query is I'll have to index that data. I can do, I'm going to use the visual editor. You can do JSON editor if you prefer working that way. And this you can also do via an API if you prefer to do that. I'm going to just keep the default settings. I only have one collection. And then here I want to point out a couple things. I want to make sure you guys can see this okay. We're indexing with the standard Lucene analyzer here. I'll come back and talk more about analyzers later. And then I'm also mapping dynamically. So mapping dynamically is really good with the MongoDB data model because your data is going to change and evolve, and mapping dynamically, it's going to take all those fields inside of that collection, and it's going to map every field, and then as those change, you don't have to, we're going to listen for those changes and map them automatically for you, so you don't have to worry about deleting your index, recreating your index every time something changes. So now that we have an index created, we have a nifty tool here inside the interface called the Aggregation Pipeline Builder. Hopefully it'll pop up. And we also have it within Compass. Usually I do this in Compass exactly for this reason. So let me see if I can make this open up again. So I'm just going to give it another second, and then I can just go on and show the app if it doesn't load up here really quickly. It is a demo. It is a demo day. It's a good way to start to pay the demo gods early for everyone. So this tool here is called the Aggregation Pipeline Builder that we have, and we have it inside Compass as well. So what I can do here is you see that we have all these documents, and I'm going to pass it through that first stage to transform the documents. And the first stage, of course, is $search. Let me move this up a little bit. So we have some nifty comments here, but they kind of crowd me, so I'm going to skip it. I'm going to I'm going to look for my favorite player. Does anyone want to guess who my favorite player is? It's Mbappe. So I put in Mbappe. Let me see if I can make this a little bit bigger. Okay. So I put in Mbappe. Right now I'm using $search. I'm using the default index to look for Mbappe in a field called short name, and I get no results. So the reason is because Mbappe is spelled with an accent on the E. So this is a misspelling, or it could be a typo, or whatever it is. So the first feature I can show you here is that we can enable fuzzy matching for your users with a simple line of code. And now I get all these documents back, and my first player is actually Mbappe. I'm looking for his name. Yeah, there he is, Kylian Mbappe here. And in the preview panel, this is really practical because I can do this and I can make sure that I'm building the stage in the right way. Now, first stage. My second stage, because I can combine $search with any other aggregation stage, I'm going to use project. And this is just I use this to sort of simplify my payload. So I just want to get the short name back. And I'm going to use the meta operator here. See if I can never search score. Okay, great. So this meta operator is going to surface the search score of these players. So the score is based on relevance. Relevance is a measure of how well, is how Lucene calculates how well your query matches these documents. And I had to use the meta operator because it's not in the actual original document. So you'll see here that Mbappe was 3.4 in the score. And then as I go down, Atlas Search computes a score for every document in the collection. So as the scores are returned to us in descending order. So if we get the highest scores first, we get the best relevance-based score. We get the best matching players first. And because I know I'm getting the best matching players first, I'm going to use my last stage here, which is limit. Now let's just limit it to 6. So now I know I have my best players here with a 6. Limit is really important in search, by the way. First performance tip, because speed is really important in search. If I know I'm getting my best matches, my most relevant matches first, I'll go ahead and limit it to 6. And in fact, I can even move it above my project, so I don't have to project all the fields across the collection. I just project those first 6. So now that I've done that, I can export the language. And then this simple 3-stage aggregation is the core of my search engine for my soccer application. So with that, let's have, let me see where I am. So that was our basic query. We're doing the index. We're using the text operator. We're going to show you a couple more text operators here and the short name. So in the application, I'm going to close this. Let's see. So I'm going to show you this application real quick. Let me make it smaller. There. So this application, it is, if you have, it doesn't work on cell phones. I didn't style it to work on cell phones yet, but if you have a laptop, you can go ahead and pull up atlassearchsoccer.com if you wanted to do this with us. It's live. And so in it, I have different players here that I've already added to my dream team. So you could find different players here. We'll look across text, which we already did, wildcard, autocomplete. And as I start looking for players, if I do Mbappe, which I just did, then here we go. We have Mbappe. I already put him front and center because that's where he belongs. And the other thing here is this is a tool for you to use. So as you start experimenting with Atlas Search, I actually put in the code to be previewed here so you could kind of see if you're building it out in the right way. So with that, let's start looking for some players. Do you want to come up and give this a try? Thanks. Who really knows the hardest players, like big fans of players with impossible names? Who's a big soccer fan? Okay, well, Iber, you don't have to hide your hands, Iber. You just don't raise them. So we'll do an easy one. We'll do Ronaldo. So go ahead and type Ronaldo. Okay, so go ahead and hit. Sorry. Yeah. So Ronaldo is actually, it's a very common name, so we have lots of different players. I've limited it to 6 pages. It probably goes on for more than that. But the thing is that I think the Ronaldo we're looking for actually starts with an O, but it doesn't matter. We're looking for the Ronaldo who's from Portugal. So one thing you'll see is this is returned in order of search relevance, but it's not in return in order of skill level. So in each of these player cards, am I not on full screen here? Okay, in each of these player cards, there's an overall score, and so this is how FIFA grades them. So one thing I could do, if I want to make sure that my users, if you see the, what's your name by the way?
Ashlyn.
Ashlyn?
Ashlyn. Yeah.
Ashlyn, okay. Thanks, Ashlyn. If you can see how your users, if you want to surface the best players for your users, I can actually take that field and I can apply a mathematical formula using that field for the overall score. to my search score. So I'm putting it here in function score. I'll just go ahead and do that. And so you can see here the preview that I just added that field to the search score, and now I have Ronaldo here at the top because he's the highest ranked 91. So where do you want to put him?
Number one, I guess.
Number
Still
one.
number one.
So he's actually he's on the left wing, so we'll put him. So if you want to add him to here, you click on where you want to put him, and then you add him here. So let's try autocomplete. You want to look for Lewandowski, maybe? Anybody? Okay.
Lewandowski. I
Yeah.
don't think I'll be able to spell that, but I'll give it a shot. Lewandowski?
Yeah.
Dowski.
Okay. So no, that's okay. That's okay. So the nice thing here is, I think it is. Let's go back. Let's try this. Okay. Actually, so autocomplete. The first things I want to show is that. Where does he go? So this is actually the player I'm looking for. I actually wasn't expecting him to show up first with only 3 letters, but you see here that we have a different operator. We're using a autocomplete as its own operator, and we have a different index because autocomplete is actually a special data type inside there. But we also we can misspell it a little bit because we have the fuzzy matching inside autocomplete as well. So let's put him. Okay, let's put him there. Okay, I have one that's really hard. Anybody Turkish here? Because I always mispronounce this guy's name. So I'm going to take it out on you, Ashlyn. His name is Çağlar Siyancı. Does anyone know who he is? I think he plays for Leicester, but that is actually something. So I have no idea how to spell that. Do you have any guesses on Siyancı?
Çağlar?
Çağlar is the first name.
Çağlar Launchner?
Siyancı. So do you hear any?
Siyancı.
I think so. Do you hear any like letters that like, are there any? So maybe it starts with an S. So we're going to use a different. Let me reset this here. So we're going to use a different operator. We'll use wildcard. So wildcard allows you to put an asterisk for where you don't know what it spells like. So you can do an S, and then maybe it's
Starlard?
no, we're doing Siyancı. Let's do the last name.
Oh, okay.
So S, and then maybe a star, because we don't know. And there's a Y, and then that's really all I know. So maybe do a star again, because there's something after that. And then hit enter again. Okay, so
Cool.
thank you. So the nice thing is that now we have 3 different operators that we use, and that I think this is it. But if I'm not sure, one thing I can do is, I'm going to put him here actually, but one thing I can do is I'm going to open up advanced scouting, and now I can look and sort of look across different things. So I can say, well, I know he's pretty good, so I can move the overall, maybe this, and I know he plays center back. So if I do that, so this is going to show, let me see if I can make this bigger. So this is going to show facets, and this is something that Andrew talked about early, that we have facets inside this. And in facets, so here you see that I've added these little search building blocks here also to the same search stage. And then the facets are interesting because it's going to show my results and how they're spread out across different countries, clubs, and positions. If you wanted the code for facets, by the way, it's a little different, but you can like open it here and that'll show you how to build it out. So the whole app is sort of click and help you teach as you go. But it reminds me that the guy is from Turkey. So if you just do Turkey and hit search, and we'll see what we get. Okay, so we'll scroll up. And there he is. So you got him.
Cool.
High five. Thanks so much, Ashlyn.
Yeah.
Okay, thank you. So we'll put him here. And there is actually one more thing I want to show before I go on. Let me reset. While I was showing these, and this is actually a problem I had when I was building it, and so I thought it was a cool lesson, so I put it in here. If I looked for players, I think I don't know. I think my kid likes Manchester United. That's the one Rooney used to play for, I think. If I were looking for players on Manchester United, using I see that I have 697 players on Manchester United, which is a really, really big team, but I'm not getting these players from Manchester United. I'm getting them through Manchester City, I get them through West Ham United, Newcastle United. So one of the reasons why that happens is because I'm using the standard analyzer on this. If I change it to keyword analyzer, I'm gonna show you how this plays out in a second. If I do the same search with the keyword analyzer, I get the 33 players on the team, and actually they're all from Manchester United indeed. So the reason is, whoops, here we go. The reason is because of the index. So if we showed you how to find results, and we showed you how to move the results around. But sometimes if you're not getting what you want as part of your results, it doesn't matter if you move around because it doesn't exist. So if you're doing searches for things that it doesn't exist, then you might want to check your index, or more specifically, your analyzer inside the index. So I'm going to talk a little bit about analyzers now. And to do that, I need to sort of take a step back and explain that when we created that search index, it's different than the traditional MongoDB index. The MongoDB index is based on a self-balancing B-tree index, and an Atlas search index is better for languages or natural languages. It uses an inverted index. So to explain this, I'm just going to walk through a quick example of that. So if I had these 4 documents, Manchester City, Manchester United, Newcastle United, and Paris Saint-Germain, if I wanted to search for Manchester United, and that the first thing I have to do is search breaks apart this corpus of data into different terms or tokens. So if I use the standard analyzer, it's going to break it down into Manchester and United. So these are going to map differently. So I'm going to see Manchester and United in these documents. Paris Saint-Germain is not involved, but I have to put him on the slide anyway. So if I use the keyword analyzer, then I only get the 1 token, because keyword takes everything and it just keeps it encased. And so that'll map as just 1 document here. So I always think about the index, an inverted index like the index in the back of the book. If I was looking for Altham Scott from our junior high school English class, I wouldn't take my works of Shakespeare and open the book and read it all the way through. I would go straight to the index to find it in, I'm going to impress you, Act 5, Scene 1 of Lady Macbeth. So the things that are written in the back of the book, if you were to keep going with this analogy, those are the terms and tokens. And of all of our different analyzers, we have these different analyzers. They will produce different terms or tokens, which are the things that will map back to your original documents. Built, every time I try and figure something out, to understand it, I build a little app around it, and then I'm like, this is kind of a fun app. So this is a little app I wrote, Atlas Search Indexes and Analyzers, and this .com, so you can use it. If you go across the top here, you could toggle across the different analyzers and understand the rules of how they are converted into terms to search across. So for instance, the standard one, lowercase is everything, so I basically put it in lowercase, the golden rules. I put these as golden rules. Lowercase is everything, removes punctuation, keeps your accents. We did that one. We did keyword, keeps everything intact. English is interesting because English actually removes very common stop words like it and the and. So words that come up so frequently that they probably water down your the meaningfulness of your results. So and then we have French, but we have over 40 different foreign languages as well that I didn't put all in here. So, and then you could just sort of play across with these sample texts that I have in the interface. So if I were to do English, knowing that the stop words, it understands stop words, it understands plurals. So for instance, if I'm looking in this one and I say Mike Lynn's podcast, if I were to look for podcast, I'll pick my analyzer using the English analyzer. Instead of podcasts, it'll match. You can see that I have a match here. But if I use the standard analyzer, I don't get a match. So you can play around with this and see how it works for you. Email is a common example I have. And then if you had your own data, if you wanted to try, let's say if you come in with your own, so you could like use this as sort of guidance of what the rules are. If I were to say, lovely day, so put in whatever text you want. It could be emails, it could be your, I don't know, UUIDs, something like that, and try different things. So I can do that. And if I can try different analyzers and see if it shows up. So if I do it is, and I use English, it doesn't show up, but it will show up if I do simple, I think. So try around with different things here and see if it works. 10 minutes left, or are you waving? It's time to go. So tell me again.
We have 10 minutes left.
Oh, fantastic. Oh, good. But I keep going the wrong way. So, okay, so I was going really fast because I thought they were going to hook me off. So I feel pretty good now. So knowing that, another rule of thumb is knowing your data. Understand your data and understand what you want your tokens to be. You know how your user is going to query it. Are they going to be typing in words in a box, free form? Are they looking for instance, I don't like to use the English analyzer. We have another database that has movie titles. So I don't like to use the English analyzer on that because like It's a Beautiful Life, like sometimes the smaller stop words they're actually very meaningful and something like that. So know your data, checkboxes, whatever that they're going to be doing to put that data in for your query, and then visualize, understand, anticipate what you think your tokens will be. What do you want your tokens to be? Knowing how you want your data to be tokenized, how you anticipate being tokenized, then you can pick the analyzer that you're going to index. Use that analyzer when you create your index, and then that index is the first line in every query. So you can use many different analyzers inside the same index definition. You could use many analyzers on the same field as well, but you can only use one index inside of a search query. So one last thing I want to cover before we go on to Q&A is architecture and performance. So usually when I start my building, I mentioned, do dynamic mapping. It was really easy to kind of create that index to start. We just clicked a few buttons and we're indexing and we think we're going. But one of the problems is performance. You're going to see that had 100 fields in it. So if I'm indexing all those fields, that's going to take up space on my disk. It shows on my nodes. It shares the same space as your MongoDB, and I'll show you that in a second. But if I know, once I build out my application, I understand the fields that I'm going to call, that's when I sort of go in later with like a scalpel, and I kind of pick out the fields that I want, and I try and be very efficient with that. So that's one thing to understand how we're sharing nodes, I'm going to go through the query lifecycle, because this is basically how MongoDB receives that query and what happens underneath the hood here. Our client sends that search query to MongoDB. So MongoDB sees $search as the first stage, and it sends it over to MongoT. MongoT is the search system. So MongoT uses that inverted index, and MongoDB uses that B-tree index. So MongoDB now sends that search stage over to MongoT, and that's going to do all the searching that we just did, everything inside that search stage. So then it's going to get all the underscore IDs. It maps back to the underscore IDs of the MongoDB documents. So it's going to take only that, any associated metadata, and maybe the stored source stuff that we used earlier, that we announced earlier this year. And it's going to send just that small bit back to the MongoDB. MongoDB is going to look up for those underscore IDs, and then it's going to finish out the aggregation, the limit and the project, and then it's going to send it back to the client. Those results are what's going to send back to the client. So something else I want to point out here, I mentioned, when you are going into production, make sure you create your index judiciously, is that the MongoT actually does a lot of stuff. So you probably don't want to do like dollar match, or you definitely don't want to do dollar sort if you're just going to sort across the score field, because it's already sorted for you. But also the sorting, the filtering, the dollar matches and stuff like that, there are operators that you could do using that inside of your search stage. So the more you can push up to search, it's going to isolate that underscore ID, and then you're going to get fewer documents. That's fewer documents that you have to look up once it comes back to the MongoD. So a few performance tips. Again, just to summarize, we're going to index judiciously for space, map statically only on certain fields, and then we also have custom analyzers. If you find that you aren't getting what you want, we actually have a way that you could bring in your own custom analyzer. Avoid lots of different stages in the aggregation. You don't have to avoid lots of different stages in the aggregation, but the best thing to do is try and filter as much as possible up top. Don't unnecessarily sort. And then be a goldfish is a good rule for life anyway, but if you fail, just try again. It'll work, and reach out for help. So we covered a lot. You could do your little happy dance. We covered all these things inside Search today in less than 30 minutes. I don't know if you guys want to take a picture of this. Just some of the resources that we have online. And in the white is Sarah's going to pass by in case you guys have questions. But in the white is applications where you could get code like this. And I also have Git repos that I can share with you as well that you could use for that. So let me see.
Thank you so much, Karen. Let's give Karen a warm round of applause. Karen is a true Renaissance woman. We covered not only search, but we covered soccer. We covered classic literature.
Ashlyn.
We had an amazing volunteer. Now we have about 3-4 minutes left for Q&A. Does anyone have a question? I will bring the mic to you.
So I guess the question is there a performance or maintenance overhead for search indexes that you have to take into account when you build them? Like, does it update in real time? Is there
the search index, it updates it rolls, right? So the search indexes, like as certain things change, assuming that they should, like when you make changes to your data, it'll map on those things automatically, provided that they're a field that you indexed for automatically. If you're indexing a new field, if you didn't include it in your original index, when you map your thing, then you'll have to download it. If you create a new index and it doesn't build, then your search queries will still use the last index that you created. So you don't need to maintain it as long as you've indexed right away. If you're adding a new field to your index, then you'll need to create a new index, and then we implement that in a rolling manner on your nodes. So it'll put on one node, if you have a 3-node replica set, it'll do one node at a time. So, but you saw in this that they actually build quite quickly. That was quite a quick amount of time to build. So, thank you.
Do we have any other questions? Coming over. Okay.
You got smart shoes on, Sarah.
Is there is there anything that we should be aware when data is in partitions or anything like that?
I can't actually hear you. Sorry.
Maybe.
Oh, sorry. Thank you. I hear you now.
Do we have to be aware of anything when the data is in different partitions and the search works across different partitions in different regions?
When you're sharding, you mean?
Yeah.
Are there considerations to take place? Yes. I don't know them off my head. I'm sorry. But let me get back to you on that.
In 6, we support search across shards. In the latest version of 6, we've added some new capabilities to search across shards. In the next session, we're going to explore some new capabilities of Ag Pipeline. But in general, you don't have to, if you sharded, no extra considerations. It behaves similarly.
So, oh,
So it's not supported in the current version, but it's
No.
supported, going to be supported in the next version.
no, I mean, it is, you can search across shards now. I know that even when we launched it, you could search across shards, but the queries have made some optimizations. I think initially it was quite scatter-gather, but now we're making optimizations to help with the sharding performance. So, hope that helps.
Wonderful. So that is it for time. Unfortunately, we don't have time for any more questions.
But I'll stay
However,
here. I'll stay here
Karen
for
will
you.
stay here. We can do other questions in this corner. Please share your feedback on this session.